Hi, this video is to help us find out a little bit more about the chemical glassware that we're going to be using in the density lab, as well as glassware that we're going to be using throughout the year. First, we have to talk about the design and function of glassware. But glassware is designed specifically for a function, and so if we can take a closer look at that design, we can start to understand what various pieces of glassware are used for. Specifically, we should be looking at the size of the base where it sits onto the desktop. We also need to look at the opening from which liquid is dispensed and any markings that it may have to determine function. First, we'll start talking about beakers. Now, obviously, some of the finer features of a beaker include the fact that it has a very wide base and it also has a lip at the mouth. It also has very few marks for measurement. Those are meant to be mostly estimation. So because of that, the wide base allows us to use it for heating, and so it's got a sturdy bottom that it won't fall over or tip over easily. It's also used for storing and also used for pouring with the lip, but volume measurement, it's not its best use. Flasks come in many different varieties. We see several right here. In this lab, we'll be working specifically with the volumetric flask and the Erlenmeyer flask. All right? All flasks tend to have a wide base, again, to give it support so that it doesn't tip over. They also have a narrow mouth, okay? And also generally have very few marks for measurement. Now, specifically, we'll talk about the Erlenmeyer flask first. As we can see, these are these triangular or conical shaped flasks at the bottom. They have the wide base and narrow mouth, which allows them to be corked so that they can be swirled. They have very few marks for measurement, much like the beaker. So we can use them for heating and storing like the beaker. However, because it's got that narrow mouth, it can be corked and thus it can be swirled as well. Even without corking, you can swirl it without fearing that things are going to come out or the liquid is going to come out of the top. Now the volumetric flask that we see down here is actually quite different. Again, it still has the wide base and very narrow neck, very narrow, not just for closing, but actually for measuring. Because the more narrow the neck is, the meniscus that will form, a meniscus even forms with a beaker, but the meniscus that forms here will actually be very pronounced so that we can get a precise measurement. There is only one mark in a volumetric flask. As you can see from the three flasks down here, one is a 250 milliliter flask, one is 200, and the other one is a 30 milliliter flask. You cannot measure any other liquid in a volumetric flask than the size that it is designed to use. Because of that, we use it to make solutions of very specific concentrations, but in order to find out what the specific concentration is, we have to know the exact volume of the material that we're making. We also can use them for storing and swirling and mixing, but the primary use is that of making solutions of specific concentration. Graduated cylinders you're probably already familiar with. As we know, they have a narrow base, though it is wider at the bottom so that it doesn't tip over. It has a narrow neck, much like the volumetric flask. That narrow neck makes a more pronounced meniscus, allowing for better measurement. It also has many graduations, not just one, so you can measure various volumes, and rather specifically. Pipettes are another piece of glassware that we'll be using. They have several features as well. Regardless of the type of pipette that you're using, they all have a narrow shaft, they all have varying marks, and they have various tips. Now the transfer pipette in the upper right hand corner is probably the pipette you're most familiar with using. It is used to do exactly what it's called, transfer liquids, small amounts, dropwise. However, volumetric pipettes, we'll talk about momentarily, deliver, like a volumetric flask, a specific volume. The two pipettes that we see at the bottom here are graduated pipettes, but they are slightly different and we'll talk about each one. Each pipette, except for the transfer pipette, uses a bulb or a pump to pull the liquid into the pipette. So the different pipette types that we're going to be working with are, as we mentioned, the volumetric pipette on the left here. It has only one mark, and as we can see with this pipette, it only measures 8 milliliters. It delivers only one volume, but with precision. Now, if you take a look at the picture directly to the right of that, you'll see that there is an 8 milliliter, and right next to it in very small print, it says TD. That TD means to be delivered. And it also says specifically at 20 degrees Celsius. We know that when water changes its temperature, it changes its density, and thus the volume will change. It also talks about how precise this instrument is. It can measure that 8 milliliters within 2/100ths of a milliliter, so a precise instrument. We need to make sure that we know how to use it carefully, which we will. The next pipette we see here is called a serological pipette. It, as well as the Moore pipette that we see on the right, both have graduations. However, if you'll notice, the graduations in the serological pipette go all the way to the tip, whereas in the Moore pipette, the graduations stop before the tip. In the serological pipette in the center, we want to dispense all of the liquid from that. It is designed specifically all the way to the tip to deliver that amount. However, in the Moore pipette at the right, we would stop at the 10 milliliter mark dispensing if that's how much we wanted to dispense. Always make sure you check what type of tip you have on your pipette before you use it so you know exactly how much liquid you're dispensing. Now, as we mentioned, there are two different apparatus to use to actually pull the liquid into a pipette. Here's the first one, a pipette bulb.
Fill any pipette up to 25 milliliters in 4 simple steps. The bulb is made out of highly chemical resistant silicone rubber, and there are 3 letters on the pipette fillers, A, S, and E. First, insert the pipette in the pipette filler. Then, press the A button to evacuate the air. S to draw the liquid up into the pipette, and E to empty the pipette. Make pipetting simple, safe, and accurate by using the Flynn Safety Pipette Filler.
We'll also see how to use a pipette pump. These are much easier to handle and we'll be using them in the lab as well.
This video will show you how to use a pipette pump in only a few simple steps. First, carefully place the top of the pipette into the bottom of the pipette pump. To draw fluid up, using your thumb, dial down on the dial at the top of the pump with the tip in the fluid. This will draw the fluid up. To express the fluid, simply use the button at the bottom of the pump. Press in to release the fluid, allowing it to stop dripping. This will deliver the correct amount. Do not push down on the top of the pump to force out air or fluid, as it will deliver more than the glassware was intended.
A burette is another piece of equipment that we'll be using. It's this one here over at the right. Now, a burette looks kind of like a pipette, but it has a narrow shaft. It also has a valve at the bottom, which is called a stopcock, which allows you to start and stop the flow of liquid. Now, the burette is used for something very specific. Okay? As you can see, it has many graduations, which tells us that it is volumetric, or that it measures volume, and rather precisely, as we'll see. It measures not just volume, but specifically an amount of volume that you dispense. We use burettes in labs called titrations. Now, the titration is a lab that wants to measure how much of a material, of a reactant, is used to complete a reaction. So we're measuring the amount of volume that we dispense. We use that value to help us with other things. So what we're going to do is see in this next clip how we can use the burette.
This video will show you how to use a burette, which is this apparatus here. It looks somewhat like a pipette, however it is filled from the top. You can see that it starts with graduated marking starting at 0 all the way down to the bottom at 50. It also has a valve or stopcock at the end to control liquid flow, held in place using a burette clamp. The squeeze allows you to put it in and take it out. The burette is filled with a funnel from the top, making sure that the valve or stopcock at the bottom is perpendicular. Then the initial liquid measurement is made. Liquid is dispensed from the bottom, and a final volume is also measured. The difference between initial and final volume represents the volume dispensed.
All right, that's all the glassware that we're going to be working with. Happy measuring. Remember, you can always use this video, go back during other labs and this lab to make sure that you're using the glassware correctly. When in doubt, ask. It's better to do that than to find out that you've been using it incorrectly and get wrong results, or worse yet, do something that's not safe. Happy measuring!